In an experiment, college students were given either 4 quarters or a dollar bill, and they could either keep the money or spend it on gum. The results are summarized in a table, and we're going to complete parts A through C below. So if we take a look at the first column, this is the students that purchased gum, 37 and then 11, kept the money, 13 and 39. The first row, students given 4 quarters. The second row, students given a dollar bill. Now students that were given 4 quarters, you're taking 37 plus 13, and that gives us a total of 50. Students given a $1 bill is 11 plus 39, which gives you 50. Now, the total students who purchased gum, 37 plus 11 is 48. And total students that kept the money is 13 plus 39, which is 52. Now, the overall total, either adding the last row or the last column, is going to give us 100. Now, find the probability for part A of randomly selecting a student who spent the money, given that the student was given a dollar bill. So, there was a student who spent the money and that was given a dollar bill. So how many students were given a dollar bill? Well, you can see that there were 50. And how many students were given a dollar bill but spent the money or purchased the gum, which is 11? Now, the conditional probability of B occurring, given that A has occurred, can be found intuitively by assuming that event A has occurred and then calculating the probability that event B will occur. Now, the conditional probability of B occurring, given that A has occurred, can be found intuitively by assuming that event A has occurred and then calculating the probability that event B will occur. Now, more formally, the probability can be found by dividing the probability of events A and B, both by occurring, by the probability of event A. So this is our formula. Probability of event B, provided that A has occurred, is equal to the probability of A and B divided by the probability of A. Now, this problem uses the intuitive approach and the classical approach to probability. So, the probability of event B occurring, provided that A has already occurred, is equal to the number of outcomes in A and B divided by the number of outcomes in A. Now, in this case, given a dollar bill corresponds to event A, and spent the money corresponds to event B. So we need to first determine the number of students given a dollar bill. Well, if we come back up here, we can see that 11 plus 39 equals a total of 50. So there were 50 students who were given a dollar bill. Now we need to identify the number of students given a dollar bill that spent the money. If we come back up here, students who were given a dollar bill that purchased the gum, there were 11. So therefore, we would say that there were 11 students. Now we need to calculate the probability. So the probability of a student who spent the money given a dollar bill is equal to 11 over 50, which is equal to 0.22. Now we want to find the probability of randomly selecting a student who kept the money, given that the student was given a dollar bill. And recall that 50 students were given a dollar bill. So identify the number of students given a dollar bill that kept the money. So let's go back up here. So if we come up here, the students that were given a dollar bill that kept the money, we can see that the number is 39. So therefore, we have 39 students. So now we're going to calculate the probability. So the probability that the student kept the money given a dollar bill is equal to 39 over 58, which is equal to 0.78. Now notice that since the students either kept the money or not kept the money, these probabilities are complements. So 0.78 is the same thing as 1 minus 0.22. Now what do the preceding results suggest? We're going to compare the probabilities found in parts A and B. The probability that students spend the money given a dollar bill is equal to 0.22. The probability that the student kept the money given a dollar bill is 0.78. Since 0.78 is greater than 0.22, we could say that the probability that the students kept the money given a dollar bill has a greater probability. So therefore, we would say that a student given a dollar bill is more likely to have kept the money.